What's up? Welcome back. In this episode, you'll see how to solve day 9 of the Advent of Code for 2023. This one's called Mirage Maintenance. We're still traveling through the desert island with some elves. And in this scenario, we are going to get some output from an oasis and sand instability sensor, which I don't know. It's giving us some output here, which has some readings, and we want to predict a future reading. So there's some instructions for how we're going to do this. The way that we work through each of these statistics, so like each row here represents a different statistic, and we want to try to guess the next number in the row. And the way that we do that is for each one, we're going to break it down until we get all the differences are equal to 0. So we extrapolate by saying, what is the difference between the first and second element? Oh, it's 3. And what's the difference between the second and third element? That's also 3. Third and fourth, 3. And then once we have all the differences from the first set of statistics, we can then say, what are the differences of those? And once those are all zeros, we know that we've reached the bottom. And then we want to build back up by adding a 0 to the bottom row. And then the previous row's last element becomes something that we can derive from the difference. So then we can say, oh, the next element in this layer is a 3 because the difference of 3 plus 0 is going to be 3. So then we have from 3 to 3. Now we know the difference between 15 and the next element is going to be 3. So we do 15 plus 3 and we get the next element. We're backing into a last element here of each of these rows. And our answer for part 1 is to go through each metric, figure out what its extrapolated next value is, sum those up, and call it good. All right, so let's grab all of this input here. We're going to say input is equal to our new input array. And what we can do is we'll say data is equal to input dot each line. And I think that's it for now. So now we want to split these into statistics or stats or something. So we'll map each line and split it and then map those to integer. So let's see what stats is. If we run this, Ruby main.rb, we got a syntax error. Where's our error? Input is assigned but not used. Oh, we have double equals here. What the? Double equals. That's not going to work. Okay, so now we have these arrays of 0, 3, 6, 9, 12, 15. 0, 3, 6, 9, 12, 15. That's our parsing our input. Now what we want to do is maybe we can just grab one stat and pull it off. And we want to say, we want to like work through this stat itself, looking at each pair and figuring out what the difference is. And that's going to give us the next layer. So we can do stat.each cons. So that's going to give us the each consecutive 2 elements. And that will yield an A and a B. So that's going to be like the left element and the right element. And we want to take B minus A, and then we can actually pop a map onto the end of this, and that should give us back the next stat. So if we P next stat here, we get back all 3s. So from the first statistic, our next layer is all 3s. And then if we were to do this same thing again, so maybe if we just copied this and pasted it for a second, and then print that out, you'll see that we get all zeros. And also another thing that you might notice is that each layer has one fewer element, right? Like the first row starts with 6 elements, then the next row or the next layer is 5 elements, then 4. And once we get to 4 elements and we have all zeros, that's when we can stop. But we need to break up this iteration and do something like until stat is all zeros, we want to do this. Yeah. This is using right word assignment. I've started to like popping on right word assignment after the end statement, just because it like, I don't know, it feels like it's moving the process forward instead of having something up here. But for now, we'll just keep it like this. And okay, so now if we print out stat at the end, we get all zeros. So if we print stat at each intermediate step here, what does that look like? Okay, that's going to give us 3s and then zeros. Now, so we're correctly like breaking down to the zeros, but how do we build back up? So in order to build back up, we need to keep track of what each layer looks like. And so the way I solve this is by creating a list of layers. And the first thing in that list is the first stat, or like the biggest record. Now what we want to do is like at each layer, we want to add onto it the current stat as we're breaking it down. So we're going to say layers dot unshift stat. This will make it so that we are pushing on those new stats to the front of the list of layers so that the layers end up looking our original is at the end. And then we have, I don't know, derivative, the first derivative, and then we have this second derivative, and then eventually we have all zeros. So it'll look like this. That way, when we iterate later, we can go layer by layer until we get to the end instead of having to like iterate through the layers in reverse. So this just helps us for later. So now we have zeros, threes, and then our final element for stat. That's looking good. So this is like part one is like breaking it down, figuring out a generalized solution to break it down to all the layers. And then the next step is to go through each of the layers. We want to go starting with the bottom layer. We want to add a 0 to this one and then move up to the next layer and so on, popping on our predicted next value based on what the previous value was. So again, we can use each cons because we want to look at each consecutive layer, and we're going to do previous and next maybe as the names for our layers. And we can break out previous. Yeah, so we're going to have previous.last will give us the last element in the previous array. In this case, that's going to give us kind of like the delta. And the delta tells us how much we need to increase the last element in the next array and add on to it. So we'll say something like next dot push, because we're adding something onto the end of the next array as we're iterating through each pair. And the element that we're going to add is delta plus next.last. Okay, so then we should be able to print out layers here and see that we've added on elements. Okay, so we correctly added on a 3 here, and we correctly added on an 18 here. So this is the key. This is the key to the puzzle. It's like we want to find all of these last elements on the last array, which was our original. This is the number that we actually just predicted, right? We predicted that the statistic would go 0, 3, 6, 9, 12, 15, 18. And we need to do that for all of the stats. So now that we have the list of layers, what we can do is wrap this all up into a function. We'll call it predict. And this is going to take in some stat, and then it will return layers.last. We want to take in the statistic and return the statistic, but with the new element at the end. So that should help us here. So now we should be able to say predict stat_first and predict stat_first. Why isn't that work? Oh, here. Okay, so now we went from the original to now having the final one. That's great, because now we can say stats.map stat, and that should give us the list of all of the different stats, which this is. All right, so this list of stats gives us 18, 28, 68. Those are the numbers we need to add up. So now we can say .map last.sum, and now we get 114, and that matches the puzzle example, 114. Awesome. Now let's grab our puzzle input. We will drop it at the end. And now we're going to switch our data to be data.readlines and run it again. And we get this huge number, 190,121. Boom, that's our puzzle input, or our puzzle answer for part 1. So that's it. So we're like breaking down the layers. We're building back up to predict the next layer. And that is part 1. In part 2, we want to extrapolate backwards. So instead of adding on to the end, we're going to add on to the beginning. And so this is actually like a relatively simple change. Rather than pushing on to the end here, this is where we're like adding on to our predicted value. Instead, we want to unshift and push something onto the front. And in this case, the delta is based on the first element in the previous array. So instead of delta here, I'm going to use prev.last. And let's also use like prev.first minus next.first. I think that should maybe work. Let's see what we get for our map. Let's test it against the example input. So this should expand the layers out in both directions. So let's p predict stat stuff first again, and just see what we're going to get back here. Okay, so now we have a -3 at the beginning, and that looks correct. So based on our test input, yeah, doing this for the example, we would get -3, 0, and 5. So it would give us -2 as like the total. So if we print this out, we got -22. Okay, so we've got something wrong here. We want to take the next, oh, this is out of order. This needs to be next.first minus previous.first, right? Okay, there we go. This is -3, 0, and 5. And if we sum those up, we get 2. Okay, awesome. So now we can test with our input, and we get 905, which was our answer for part 2. That's our puzzle answer for part 2. Awesome. So that is a working solution. So we built up these layers and collected up a list of lists, and each list of lists let us build onto the ends of either. One of the things that I thought about for making this like even cleaner is breaking or using a destructuring here, array destructuring, to grab like the P1 and then ignore the middle and then grab P2. This is like our deltas. So now we can say subtract P1, and we can actually do like next.last plus P2. I think that should give us the same answer, 905. So that's looking good. And then this, we could probably unshift the entire thing all at once and simplify this map into _2 minus _1. And using the named arguments or whatever, the named block arguments. This one, just a lot of messing around with arrays. I was thankful that it worked and fit in memory, because I think there's probably also a solution where you can, you don't have to go as wide as all these numbers necessarily, right? If you end up with some set of zeros at the bottom that is bigger than 3, then you can trim the edges if you need to. But yeah, glad we didn't have to do that in this exercise. All right, that's it. Thanks so much for watching. If you're following along with the series, hit that subscribe button, and we'll see you in the next one. Cheers.